Hello YouTube and welcome back to another video. So today we'll be learning about how to graph the square root of a function. So this video is going to be a bit different. It's not going to follow the traditional structure of this playlist. So I'll be both recording the lesson and also doing the practice work in the same video, which is this video. So let's get straight into it. So the first point here says keep each x value the same but take the square root of each y value. So whenever you want to take the square root of a function, when you're given a graph of a function, let's say you're given a graph of, I don't know, let's say this is the function x cubed. Let's say you're given a graph of this. Whenever you're taking the square root of this function, for example, you always want to keep each x value the same, but take the square root of each y value. So for example, this point here, you want to keep the x value the same, but just shrink down the y so it ends up there. We'll do some practice work on this, don't worry. So the next point says, when taking the square root of each y value, they must be greater than or equal to 0. So right, yeah, you don't want to take any, you don't want to take the square root of a negative number. For example, let's say we have the same function here, and let's say we want to take the square root at this point. Well, this is a negative y value, say this is negative 4. We can't really take the square root of negative 4, that's not possible, so you don't want to take the square root of any negative y values. Also, the domain of the square root function, the domain of the square root of a function is restricted to all the x values of the original function that map to a y value greater than or equal to 0. So right, yeah, just the original function, any x values that map to a y value greater than or equal to 0. So let's move on and do some practice. So this question asks, graph the square root of this function in the color blue. Okay, let's start off. So if you remember this point above here, it says keep each x value the same, but take the square root of each y value. So that's what we're going to do. So let's start off with the point x value 0. The square root of 0 is just going to be 0, so we're going to keep that point there. And let's go to the point 2, 4. So it's going to be at 2, 4. The square root of 4 is going to be 2, so we can keep the x value the same, but we're just going to take the square root of the y value, so it's going to be at 2, 2 instead. Let me get rid of these so you can see the function a bit better. There we go. And let's do the same thing on this side. Negative 2, 4. So this is at this point. The square root of 4 is going to be 2. So it's going to be negative 2, 2. Because all I'm doing is I'm taking the square root of the y value. So this is at negative 2, 4. All I'm doing is this. I'm just going to take the square root of 4 while keeping this the same. This is going to be the same. So let's keep moving on. So we got 3 points. Let's move on to another clean point we can do. So I'm looking at the point 3, 9 right here. So this is at the point 3, 9. So we can take the square root of that. So this is, instead of at 3, 9, we're going to take the square root of the y value. It's going to be at 3, 3. So the square root of 9 is just 3. So it's going to be at 3, 3 right there. And same thing on this side. This is going to be at the point negative 3, 9. Just take the square root of 9 and keep this the same. And we will just be left with negative 3, 3. So right about there. And let's take a look at these points down here. So the points 1, 1, the square root of 1 is just going to be 1. So you can just keep this point the same. This is known as our invariable points. Invariant points, sorry. Yeah, these points are known as our invariant points. Basically, any points that remain the same after any change applied to the function. So I can actually write that here. That's a cool definition to know. So you can say invariant point is, let me do this in the text because that's probably better. So let's go here, text, invariant points. Any point of any point that remains the same after any change made to a function. There we go. So that's an invariant point. So basically, even after we took the square root of this function, this point remains the same, the point 1, 1. And also the point negative 1 also remains the same, negative 1, 1. Go back to blue, because the square root of 1 is also going to be 1. And there we go. And we can connect the dots here. And notice, before we connect the dots, we want to look at the behavior, because it isn't going to be just like this, because that would actually be wrong. But because that makes sense, because inside, between the values of 0 and 1, we're looking at y values that are less than 1. And if you remember, the square root of anything that's less than 1, for example, 0.6, is going to be greater than 0.6. It's going to be greater than 0.6. anything you take the square root of something less than 1 is going to be greater than whatever it is. So we're actually going to be drawing our behavior like this. So this is what our graph will look like. Probably not that steep, maybe something like that. That's probably more appropriate. There we go. And there we have it. Let's move on to the next question here. So graph the square root of this function in the color green. Let's do that really quick. So let's start off. Let's check at the point 0, -4. So we're at 0, comma, -4, this point right here. And let's try to take the square root of -4. Square root of -4. That's not possible. And if you remember from our point above here, when taking the square root of each y value, they must be greater than or equal to 0. And since this y value right here is at -4, that won't be possible. So we're not able to actually take the square root of -4. So we're going to leave that out for now. And let me get rid of these right here. So instead of taking square roots from negative numbers, let's move on to some positive numbers. So I'm just going to start off with 0 here because we can take the square root of 0. So this will be the same. So at the point 2, 0, the square root of 0 is just going to be 0. So we can write that in. This will be our new point. And same thing with this, -2, 0. Square root of 0 is just 0. Keep the x value the same. Let's move on to the point 4. So this would be at the point, this is at 3. This is about 2.7, so you can say 2.7, comma 4. Now this will be transformed into 2.7, comma 2, because we just took the square root of the y value here. So it's going to be go down to right over there. And same thing with this side, because it's a mirror, it's quadratic, we need the same thing here. It will be right there. Let me get rid of this here. And we'll do a couple more points after this just to make sure we got the shape all correct. And should be good enough. Okay, let's pick out just 2 more points here. So let's say at the point 9, at the y value 9, we can just take the square root of 9. That's going to be at 3. So we can say whatever this is, we're going to keep the x value the same, but just go down to the y value 3, which should be right there. Perfect. And same thing on this side at 9, so this is going to go down to 3 right here. Perfect. Let me get rid of these lines I made and dots because they are not in our function. Whoops. That should be good. And now we can actually start drawing in our behavior. So again, we're going to draw our behavior like this because the square root of anything less than 1 is going to be greater than whatever it is. So we can include arrows right here. And just like that. And notice how there's nothing in between this area. There is nothing because all these y values are negative here. Like if you take a point at any point of these, they're just going to be negative. So that's going to be not possible. So there we have it. We graphed the square root of this function. Let's move on. So given the equation f of x is equal to the absolute value of x, determine and graph the equation of g of x is equal to the square root of f of x. So let's first of all determine this equation. So it looks like to me what g of x is. Let me pick out a nice color here. Say red. G of x just looks like it's the square root of f of x. So we can actually write in the equation of g of x. So we can say g of x is equal to our normal function f of x, which is just the absolute value of x. Whoops. Pick out the color here, which is just the absolute value of x. But we're just going to be taking the square root of that. And there we go. And we can even, I think, yeah, this is good. So now that we got our equation of g of x, which is just the square root of f of x, let's start graphing this. So I'm going to start by graphing out the function f of x, which is just our standard absolute value function. So I'm going to start at the point 0, 0, go to 2, 2, 4, 4, and so on. Same thing on this side. Let's keep going, and we can connect the dots. So it's going to look something like this. Try my best to draw as straight as possible. There we go. Let's include arrows. Actually, I'm going to draw a bit higher. There we go. And let's include some arrows, and there we go. So now all we have to do is draw the equation of g of x, and since g of x is just the square root of f of x, we can just take the square root of each y value. So for example, at the point 4, 4, it's now going to be at 4, 2, because we just took the square root of the y value, and the point 0, 0 is going to be the same right there. The point 2, 2 is going to be at the point 2, square root of 2. What's the square root of 2? I think the square root of 2 is, let me actually look that up. Square root of 2. I believe it's like 1.4 something. Yeah, so it's going to be around 1.4. So roughly equal to 1.4. So you can draw that in right there. And same thing on this side, 1.4. And there we go. Draw that in a bit bolder, okay. And same thing with 4, negative 4, negative 4, 4. It's going to be a negative 4, 2. And any other points? Let's do the point 9. So at 9, it's going to be at 3. So it's whatever. Keep the x value the same. Just scroll down to 3. That's going to be right over here. Same thing with this side. Let's just do it here. And since this is at the point 9, we can go all the way over here. That's going to be right there. We can just go down to 3. And there we go. Okay, we get rid of some of these lines so it's easier to see our final function. There we go. Okay, so now let's graph in our function. So remember, below 1, we're going to have values that are higher. So we're going to go something like this. This is going to be our behavior. Let me draw that in a bit neater. Connect the dots. There we go. And there we go. There is our function g of x. And that's it. See you in the next video.